Hello everyone, this is Sanjay from CCT branch. Today my concept video topic of computer organization architecture is memory interfacing. Okay, in this video we are going to learn about interfacing, memory interfacing, input output interfacing, and IO mapped and memory mapped. Interface. An interface is a medium through which two separate components of a computer system exchange information or interact with each other. The exchange can be between software, computer, hardware, peripheral, humans, and combination of this, and the memory interface and input-output interface. Memory interfacing. Memory is made up of registers. Each register is a memory is one storage location. Each location is identified by an address. Each register consists of storage element, flip-flops. It is the smallest storage which we can store the data, and element stores one bit of data. Storage element is called cell. The data stored in a memory by a process is called writing, and are retrieved from the memory by process is called reading. Memory structure and its requirements. The read-write memories consist of an array of registers in which each register has unique address. The size of memory is n star m as shown in figures. And here it is the logic diagram of RAM, where we have the write class and read class and the input buffer and output buffer, and here it is an internal decoder and read and write functions, memory, and 2040.8 bit, and it is the logic diagram of EPROM. Actually, ROM has been classified into ROM, EPROM, EROM, EPROM, and here we have internal decoder, output buffers and output data, and read function. So from this diagram we are telling that where n is the number of registers and m is the word length in number of bits as addressed in figure A. This figure, as shown in figure A, memory chip has 11 address lines A0 to A10, one chip select and two control lines, read to enable output buffer and write to enable input buffer. The internal decoder is used to decode the address lines. And figure B, this figure shows the logic diagram of a typical EPROM, erasable programmable read-only memory with 409K register. It has 12 address lines starting from A0 to A11, one chip select, one read control signal. Since EPROM does not require the write signal, EPROM or EPROMs is used as a program memory and RAM as a data memory. The following table summarizes the memory capacity and address lines required for memory interfacing. 1. Memory capacity address lines required. 1K is equals to 1024 memory locations, and 2K is nothing but 2048 memory locations. The address lines required are 11, and the 4K is equals to 4096 memory location where 12 address lines are required, and 8K 8192 memory locations where 13 address lines are required. 74LS138 decoder and demultiplexer. It is also called as MUX. A decoder is MUX is nothing but many inputs to the single output is now called as decoder, and also multiplexer. Demultiplexer. A decoder is a logic circuit that accepts a set of inputs that represents a binary number and activates only the output that corresponds to the input number. In other words, a decoder circuit looks at its inputs, determines which binary number is present there, and activates the output that corresponds to the number. All other outputs remains inactive. In its general form, a decoder has n input lines to handle n bits and form 1 to 2n output lines to indicate the presence of one or more n-bit combinations. The following figure shows the block diagram of the decoder, and it is the block diagram of the decoder where we seen that a0 to the power to the there are n inputs, the first one starting from a0 and the last one from n minus 1. If it is a 8k, then the address lines are 1 to 14, but here it is n minus 1, so 14 minus 1, 13 inputs, and same as outputs, only one output is high for each input code, that is A0 to m minus 1. It is ranging from 0 to m minus 1. The LS138 is a high speed of 1 of 8 decoder, 3 to 8 decoder. It could also be a binary octal decoder or converters because it takes a 3-bit binary input code and activates the one of the 8 outputs corresponding to that code. It is referred to as a 1 of 8 decoder because only one of the 8 outputs is activated at one time. The pin diagram and the truth table of decoders are shown in the below, and this is the diagram of the pin diagram of one of the 8 inputs. And now this is the truth table of the 8 inputs. X is don't care conditions, where inputs are enabled, select, and outputs are. Basic concepts of in-memory interfacing. 8085 accesses 64 kilobytes memory. Since its address bus is 16-bit, it is not compulsory to use full of 64 kilobytes address space. The total memory depends upon the applications. Usually, EPROM is used as a program memory and RAM used as a data memory. Number of EPROM and RAM depends on requirements of the applications. Microprocessor can communicate, read and write with only one device at a time. Since the data, address and control bus are commonly for all the devices, decoding is necessary to communicate with the devices, memory and input-output devices. The common address decoding techniques are absolute decoding and linear decoding. Absolute decoding. In the absolute decoding technique, the memory chip is selected only for the specific logic level on the address lines. No other logic levels can select the chip. Below figure, the memory interface with absolute decoding. Two 8K EPROMs 2764s are used to provide even and odd memory banks. And this is the diagram of absolute decoding technique. EPROM, RAM, control signals BHE and A0 are used to enable output of odd and even memory banks respectively. As each memory chip has 8K memory location, 13 address lines are required to address each locations independently. All remaining address lines are used to generate an unique chip select signal. This address technique is normally used in a large memory systems. And next we are going to see about the linear decoding. In small system hardware, for decoding logic can be eliminated by using only required number of addressing lines. Other lines are simply ignored. This technique is referred as linear decoding or partial decoding. The address line of A15 is used to select the chips. When A15 is low, EPROM is selected, otherwise RAM gets selected. This technique reduces the cost of decoding circuit, but it has drawbacks of multiple addresses. And here this is the diagram of the linear decoding, where you can see there it is of 7 for LS138 and of EPROM and RAM. The above figure shows the addressing of the RAM with linear decoding technique. EPROM is selected when E15 line is high, RAM is selected when it is low. The status of other selected lines are not considered since those address lines are not used for generation of chip select signals. So today in this topic we learned about the memory and input-output interfacing. Actually it is nothing but a microprocessor which connected with three buses. One is address bus, data bus and control bus, and every of these bus is connected to the memory, and every of the memory is control bus is connected to the input and output devices. Memory interfacing. So recall that when we are executing any instruction, the address of memory location or an input-output device is sent out by the microprocessor. The corresponding microchip or input-output is selected by the decoding circuit. Memory requires some signals to read and write to registers. Microprocessor transfers some signals for reading and writing of the data. So today we learnt about the micro memory interfacing and input-output and linear decoding and absolute decoding. Thank you.